So today the problem that we are going to solve is 3607, which is a power grid maintenance, and it is a medium read code problem. So basically, question is saying you are given an integer C representing C power stations, each with unique identifier ID. So basically, we have C power stations, and all the power stations have a unique ID, means basically indexes number from 1 to C, and there are n bidirectional cables between these, which is given in 2D array connections is like UI comma VI. So basically it means that there is a bidirectional cable from UI to VI, and all, so suppose you can assume it like a graph. So like all the power grids, power stations are the nodes, and bidirectional cables are the edges. Now one connected component is called a power grid, and initially all the power stations, all the nodes are operational. Now we have two types of queries. First, let us understand if the query is of type 2, then we have a node and node goes offline. If we have a query 1, then it means that a maintenance is required, and if X is online, then maintenance will be done by X, and if X is not online, then the maintenance will be done by the smallest ID of that power grid. If there is no operational ID, then it will be -1. So let us we have to result means output list for all the queries, for answers for all the queries of type 1 comma x. So see, let us see the answer. Let us see test case, like queries is 1 comma 3. So for 3 is online, so 3 will be the output, 3 is the answer. 2 comma 1, now 1 is turned off, and now 1 comma 1. So since 1 is turned off, so the least ID, smallest ID which is currently operational in this grid is 2. So the answer will be 2. Now suppose we have turned off 2, and now we are asking answer for 2. So 1 and 2 are already offline. So 3 is the least one. So that is the answer, right? So now let me tell you my approach. So my approach is something like, see, what we can do is, okay, so what we can do here is, suppose there is a graph, right? There is a graph, and we have this graph, and we have another graph, means not the another graph, but it's another component, another grid. So what we can do is, like, we will perform a DFS, and in each DFS we will assign a particular ID. Suppose for this ID is 1, so all the nodes will be given ID 1, right? And for second transition, what we will do is we will provide ID 2 to all the DFS nodes, and then what we will do after that, after the DFS is complete, for all the nodes we will run swap and loop, and for all the nodes, and we will check the groups, and in group 1 we will list down all the, basically we will take a sorted list, and we will list down all the nodes that are there. Now for the group 2 we will do that same, and now these all are the online nodes. Now what happens, suppose we have listed query of type 2, so we will remove that, we will find a group for that node, which is group. From that group we will eliminate that from the online, because these are currently online nodes. Now if we have a query of type 1, then what we will do, we will search if in that group, because we have the group for all the nodes, so we will search that particular group if that node is currently online. If it is not online, we will take the smallest number that is online, and if size is 0, we will return -1. So this is my approach. Now let me take you down to the code which I have used here. See, so my code is something like, I think this will be okay. It is negative, I don't know. So my code is something like, see, what I am doing, basically PS is the visited array which is storing the index, means the ID for a particular DFS. So for all the nodes currently it is 0, and it is a adjacency matrix. So what I'm doing, I'm building adjacency matrix adjoint of u dot append and v dot append from the connections. Now t is equal to 0. T is the ID for particular DFS. Now I am iterating from all the nodes, and if it is not visited, it means we can run a DFS. So we will be running a DFS for this new component with a unique ID. And now we are passing this ID to a DFS. Right? And in DFS, what we are doing? In DFS, in the visited array, which is PS. So for a particular node, we are providing that particular ID, and then all adjoint nodes which are not visited till now, we will run DFS for that, and we'll pass the same ID so that a particular ID provided to whole DFS, whole node covered in one DFS. All will have the same ID. Now see what happens. We are running through all the nodes, and we are okay. Now we have completed the DFS part. Right. Now, the size of the T is the number of groups we have. So we are taking a sorted list for size T plus 1 so that we can have index in T. Now what we are doing, we are iterating over all the nodes, and for the particular group, whatever group they belong, we are adding that to the group, and we are adding that to the node to do. Now, here comes our answer, which is list. What we are taking for queries, we are taking q comma node, and if query is equal to 2, means the query is number 2, then what we are doing, if the particular node is already present in the group, so we are we will say from self.ps node, we are getting the group, and in that group, if the node is present, we are removing it. Otherwise, we are finding the what is the group number of that node if it is of type 1, query of type 1, and if the node is present in group G, then append it answer in the answer. Otherwise, if the length is greater than 0, then append smallest element which is currently online, else append -1, and at last return answer. And I think it will answer. Fine. I hope so. And, uh, uh, so thank you.